This is the second lesson in naming chemical compounds, and right now we're continuing on with ionic compounds and polyatomic compounds. So when you're looking at these things, you have to remember that we're still following ionic rules. And so when you're looking at the ionic rules, you want to remember that the plus ions are going to equal the negative ions. Okay, so when you form the compound, that plus ion is going to be the negative ion. But so the multivalents, when you talk multivalents, some metals, and actually some non-metals, but right now we're just going to look at some metals have more than one valence. So they have more than one charge option for the ion. Okay, so if we look as an example here, if you go to the periodic table of ions and you look up iron, okay? So iron, if you go to the periodic table, it exists in nature as two different ions. It can be either the Fe2 plus ion, or it can be Fe3 plus, okay? And they behave differently with with the negative ions depending on what's happening. So you have to think about it when you're writing names for the ionic compounds, we need to know which is which. And so when we're doing multivalent, I'm just going to go to a page. So when you do multivalent compounds, okay, the name, if you're writing the name, must include which valence is being used. And in fact, this actually makes it a little bit easier because when you look at the valences, it'll already tell you in the name. So an example here would be iron 2 oxide versus iron 3 oxide. Okay, see in the name, we've used Roman numerals to indicate which valence is being used. So if we were asked to write the chemical formula for this, that would be Fe, we know it has a 2 plus charge, the ion. Oxide, well, it has a 2 minus charge. So those equal, remember, when we're doing ionic compounds. So iron 2 oxide will just be FeO. Whereas iron 3 oxide, well, that iron has a 3 plus charge. Oxide is the 2 minus. They don't equal, so you need at least another negative in oxygen, but the oxide can only do it in 2s. So now you've got 4. Well, now Fe has to have another one, so we can only do it in 3s, so that's now 6. Oh, and then we go to 2 minus. So now we're left with Fe, there's 2 of those, and 3 oxides. So iron 3 oxide is Fe2O3, whereas iron 2 oxide is FeO. So when you're looking at multivalent compounds, when you're forming them, the name already tells you. So when you're looking at the name will already tell you which valence is going to be used in the metal. And the other one, oxygen, when it's an ion form, oxide will always have a charge of -2, so you can figure that out. Okay, so that's writing the chemical formulas. Figuring out the names here, and you're looking at the charges and what's possible, figure out the names. If you're given the formula, you just have to work backwards. So if you're given the formula and you have to produce the chemical name, okay, so I'll give an example here, PbO2. And so when you go and find on the periodic table, lead, Pb, exists in two forms. It exists in 2 plus, or it exists in 4 plus, okay? And you have to figure out, well, looking at PbO2, would it be lead 2 oxide, or would it be lead 4 oxide? And the way to think about that is if you go back, if you go forward, well, I know that there's one lead and there's 2 oxides. And I know each oxide is a -2. And I know that they have to equal, the charges have to equal. And so that's going to be a 4 negative. That means the lead must be 4 positive. And since there's only one of them, then I know when I go to write the name, I know that's going to be lead IV, which is 4 oxide. Okay, so when you're looking at it, lead 4, because there's only one of them in the original, and we know that having 2 oxides is going to give us an overall charge of -4 if they were by themselves, which means lead has to be a positive 4, okay? So when you're looking at multivalent and you're trying to name it, just work backwards with the numbers that you have, because one of them won't be multivalent, okay? So hopefully that makes a little bit of sense. All right, let's talk, and we're going to talk polyatomic ions, okay? So polyatomic ions, a simple way to look at it is poly, in a generic sense, means many. Atomic, many atoms that make up the ion. So far, when we've been talking about simple ionics, when you looked at simple ionics, you had one metal and one non-metal. Okay, that's what it made. So you had a plus ion and a minus ion, and that was 2 elements. If you were to look at it just in the general sense, you're looking at 2 elements. When we're looking at polyatomics, we're looking at more than 2 elements that make up the compound. So I'm going to give you an example if you were looking at it. An example such as Na2SO4. Because remember, in a simple ionic such as NaCl, that was 2 different elements. Well, here you've got sodium, you have some sodium, you have sulfur, and you have the oxygen. So you have 3 different, so you have a poly, not just diatomic, okay? So when you think about this, now you have to start looking at the polyatomic ion chart. And the polyatomic ion chart will give you the name of the polyatomic ion, the formula for the polyatomic ion, and its charge. Okay? And so if I go and I look for my polyatomic ion chart, I know that the first one, that's just we're looking at sodium, so Na, so that would be sodium, because that's in the periodic table. And then SO4, if I look for it, I'm going to find it in the periodic table, and it's called sulfate. Okay, and so the chemical formula of Na2SO4, the scientific name is sodium sulfate. Okay, and I could look at another one, and I'll give you a name one now. So I'm going to go a name such as let's go with calcium nitrate. Okay, and look, it's ending with an 8. It's not an "ide." That's a really good clue that it's a polyatomic ion. Okay, we'll go through the names and stuff in a few seconds. But if I was to go look for that, calcium's in the periodic table. Okay, so if I'm looking for calcium, it's Ca, it's got a charge of 2+. And then I look at the polyatomic ion table, and nitrate is NO3. And it actually has a charge of 1 minus. Okay, and since we're still talking ionic compounds, we know that pluses have to equal the minuses. And so if I was to do this over here, calcium is 2 plus, nitrate, we treat it as 1, is 1 minus. So we need another nitrate, which is another 1 minus. So now we've got 2 here, so we're good. When we write it out as a formula, it's calcium, and the nitrate is that, okay? So when you're looking at polyatomic ions, you need to think of the polyatomic ion as sort of one entity in itself with one charge, okay? So some hints for polyatomics. If the name, so if we're starting with the name, if it ends in ate, or the term hydroxide, because hydroxide is a specialized one, or cyanide, those are polyatomic ions. And there is a positive polyatomic that we want to consider and remember, and that's ammonium. You won't find ammonium in the periodic table. You'll have to find it in the periodic table of, you'll have to find it in the polyatomic ion chart. So if it ends in ate, hydroxide, cyanide, or starts with ammonium, it's a polyatomic. So find it in the table. That's not the periodic table, but the polyatomic ion table, okay? And when you have to name it, when you have to come up with the name, if it's the polyatomic, use the name. Don't change it at all. Okay, so let's take a look at aluminum hydroxide. Let's just erase that 1 second. When I see that, I'm like, oh, hydroxide rings a bell. That's up here. Okay, so that's a polyatomic ion. Aluminum, okay, so I'm going to find aluminum in the periodic table, and I know aluminum, and I find it, and it has a charge of 3 plus. Hydroxide, when I look at hydroxide, it's OH, and it has a charge of 1 minus. Well, we have to charge it up and make them equal. So 1 minus, OH, 1 minus. So now when you draw it out, it's aluminum hydroxide, okay? So you need the parentheses, okay? You need the brackets if more than one of those, if you need more than one. Okay, so here's one that does not need more than one. Potassium permanganate. For some reason it's permanganate. Okay, okay. So when I look at that, I'm going to go look in the periodic table. Potassium, it has a 1 plus charge. Permanganate is MnO4, and it has a charge of 1 minus. So they're already equal. So potassium permanganate is KMnO4. There's no parentheses, note, no brackets. Not needed. and they shouldn't be there if only one polyatomic ion needed. Okay, so that's basically the lesson on multivalence and polyatomic ions. Hopefully that makes sense. Again, please feel free to email and ask questions if it does not make sense. Have a great day.